For some reason, my display. Hold on a second. Now, question is, why am I not able to expand that? I've been having this problem lately on trying to think of what to do. You see if I open another page where that matters or not. I can't imagine it's going to. It's not. Did. Okay. Let's start with what we can see. I apologize for the blurriness of it. But can you read that?
Yeah, I can read it.
Okay. Let's do number 7, which pertains to the drawing. Okay. So what's that measure of that angle BFG?
Oh, let's see. 40.
Here's the underlying principle. 2 parallel lines and a transversal. You create 4 angles, or 8 angles, right?
Mm-hmm.
But you only create 2 unique angles. In other words, 1 and 2 are supplementary, and everything else is either 1 or 2. Notice that 3 is 2, 4 is 1, 5 is 1, 8 is 1. You know what I'm saying?
Yeah.
So in this picture, here's our transversal. You got to kind of learn to eliminate lines that we don't need.
Okay.
The only thing they've told us that's important is this line is parallel to this line. And that's a straight line transversal. So what's this angle right here?
140?
140, exactly. In other words, the only thing you need to determine is it's the obtuse angle in this picture up here. One of those angles is acute, 2 is acute, 1 is obtuse. Everything else that's either obtuse or acute is either 1 or 2, and 1 and 2 are supplementary. That means 4 and 6 are supplementary, and 3 and 5 are supplementary. And that's the situation we're looking at here. Is when we're looking at this picture here, we're looking at 3 and 5 basically.
Yeah.
Consecutive angles, or I should say side-by-side angles. Now, let's examine another way to do that problem. Okay, there's our answers. It is clearly not 40, not 80, not 90, and not 180, right?
Mm-hmm.
In other words, we can absolutely eliminate that answer, even if we don't know about parallel lines, by just looking at it. We can see it's obtuse, so it's not 80. It's obtuse, so it's not 90. It's not a right angle. And it's not 180 is all the way. That's a 180 angle right there. So it's short. It's more than 90 and less than 180. There's only one answer on there like that.
True, yeah.
There's never a reason to miss that problem. That's a gift merely because of the answers they gave. They should have put
Yeah.
a 140 and a 130 in there or something, at least to make it so you had to know the principle involved.
Yeah, at least you had to think a little bit more.
Okay, number 8. Can you read that okay?
Yeah, I can read it.
Okay, so what are we going to do? Tell me how to write it out. Let's pretend you're taking a test and you got to show your work.
Okay. I do -3 squared.
In parentheses. Parentheses are very important there.
And then minus 6 parentheses -3 minus 18.
Okay, now simplify it. That's always the best way to go on these problems. I don't do these in my head in one step. I do it exactly this way all the time.
Mm-hmm. So 12 minus plus 18.
What does that become?
Plus 18. Minus 18. Yep. So that's just 9.
Uh-huh. Okay. This is an absolute value. They're saying what is the value of 1 minus a? How dare they use 1 in the same problem with an absolute value sign. When a is equal to 12. It's the absolute value of that.
-11.
Okay. Now, let's see if I can go to the next page. Oh, actually, I need to scroll down. No, I can't scroll, so I want to go to the question 10. Actually, I can see 10 on there. I just can't blow it up. Huh? No, I can't scroll down to my programs start working really funky here. I'm not quite sure what to do, how to fix this. I've been experiencing this for about a week where I can't get access to the edit. There it goes. And I can do this, but I can't scroll down. But I guess for our purposes, we don't need to cover every problem. We're randomly problems. That's actually a fine way to go.
Yeah.
So let's do 13.
Okay.
Never a bad idea to draw a picture.
Okay.
And divide it up into 12 sectors. Well, there's 4 sectors. I think that's 12 sectors. We'll assume it is. And they want to know the total measure in degrees of 5 of those sectors. That area right there. And we know the circumference is 46 pi. I purposely didn't write that on there for a reason. In fact, let me erase it. Is it needed?
No.
No, not at all. Doesn't have anything to do with the solution. Just another example of where ACT puts information on some of these problems that's completely irrelevant and to try to lead you in the wrong direction. What's the measurement if I went around the whole circle?
360.
Okay, what's the answer to this?
60.
No, conceptually, what part of this circle are we looking at?
The shaded part.
Which is what percent? What fraction is that?
Oh, okay. That's
There's 12 sectors. We're looking at 5.
5 out of 12.
5 over 12. We're looking at that fraction of the circle. And now when I do that math, that goes into that. 30 times 5 is 150. Okay? That's the easiest way to do it. The other way to do it would be to know that the circle's divided into 12 sectors, therefore every sector is 30 degrees. Right? That's 30 degrees right there. That's 30 degrees. They're all 30-degree measurements.
Mm-hmm.
We got 5 of them. 150 degrees. So that method is kind of 2 steps. This method is 1 step. The key to this problem is ignoring the 46 pi, because that can lead to a lot of wasted time and effort. In other words, if you start thinking the 46 pi, just really, if they don't put that in there, this is an easy problem. The fact that they put that in there makes it a little bit more of a difficult problem. All right, number 14.
Okay.
What are we going to do here?
Find the average, basically.
Okay. You know how to do that. We won't go through that.
Yeah.
Notice
Okay.
another piece of irrelevant information.
730. Yeah, I don't know how you'd incorporate that.
You don't. It's not. It's strictly meant to throw you off. They could have said every day. They could have left that off and said every day during one school week would have been exactly the same problem, only easier. Well, we're just going to have to jump around here, I guess. I got to. All right. I'll just go through every page and see if I can get it to a size where we can at least see it. Apologize.
Okay.
Then I will hopefully have this fixed. There we go. At least we can see a few problems. Let's start with 18.
Okay.
Let me ask you the same question that I kind of got in the habit of asking you with the SAT. And that is, what method are you going to use to solve this? You're going to solve this algebraically, or is there another method you could use?
I think algebraically make no sense.
Okay, let's do it algebraically.
Okay.
Where do you start?
Do 1 plus 1x equals 510.
No, if you're going to do it algebraically, you're going to need 2 variables. You're going to need a variable for popcorn and a variable for the drink.
Okay.
Okay.
So like,
then you're going to be able to do 2 equations with 2 unknowns, and you're going to solve that system of equations, right?
Yeah.
Let's look at a much easier way to do it. There's no variables in any of this, so it's not pick numbers. What's the other method? That's one of the best methods to use.
Elimination.
Back solving,
Next.
which is elimination, basically. But
Oh,
back
okay.
solving is where you pick one of the answers, you see if it's correct, and most of the time, if it's not correct, it'll tell you which direction you need to go. And so back solving is going to be a lot faster than algebraic. So we're going to start. What's the cost of one drink?
Let's do like $1.85.
Always start with the second lowest or the second highest. So let's test that. Okay. Now, if that's the cost of one drink, then the cost of one box of popcorn has to be what? $3.05? No.
Yeah.
Let's
Something
plus $3.15.
$3.25.
No, $3.25. Jeez, I can't do math here all of a sudden. So if the cost of one drink is $1.85, then the cost of one box of popcorn would have to be $3.25, right? That's the only way they could be worth $5.10.
Yeah.
Now let's see if that fits for the second equation. We know the cost of one box of popcorn is, so the cost of two boxes of popcorn is going to be $6.50 plus the cost of one drink, and that gives us $8.35. Bingo, we picked it correct on the first attempt. But I don't want it to be that easy. You don't always get it correct on the first attempt. So let's go back and redo the problem with either G or J is satisfactory to use. Okay?
Okay.
So let's say we started with J instead. Well, now the box of popcorn has to be equal to 355, excuse me, for them to be worth 510. No, I was correct the first place. 255. Geez, I stopped tutoring for a day and I forget all my math. Okay, so now does that satisfy the second one? Well, two boxes of popcorn would be 510 plus the drink, which is 255. That's 765, which is not 835. But more than telling us that it's not correct, what does it tell us? Which direction?
We have to go up.
Down. We have to go down. In other words, making the cost of a drink be $2.55, the cost of two popcorns be too small. See, it's not 100% clear which direction you have to go. It's a little bit opposite in this problem. Most of the time, when you use back solving, it's going to 100% of the time tell you which direction to go. This one, I'm a little unclear. I kind of feel like maybe I got to go higher, but I think I got to go lower. So if I decide I got to go lower, my next choice is definitely G. It is not H. It is not F. It's G, and G will tell me one way or the other what the answer is. If G is not correct, I'll know at least that I went the right direction, and so I'll know H is correct. If G is still too big, I'll know F is correct. And if I went the wrong direction, then I know K is correct. So even if you can't be certain that the direction you need to pick your second pick, you usually can work it out. In other words, and in most of the cases, you usually are certain. Whenever you get age problems or marble problems, John had 10 marbles, somebody else had 3 times as many, and somebody else had 5 less than the second person. Problems like that are perfect back-solving problems. You always know exactly which way to go if your first guess is not correct.
Okay.
All right, let's look at 19. You have your calculator in front of you, Ben?
I have a calculator.
That's fine. Why don't you,
Okay.
you should always have one. You probably want to have the one that you're going to use in the test. When you took your SAT, what calculator did you use?
My TI-84.
Okay, and they allow that in the ACT also. So for our sections, that's the one you should have in front of you.
Okay.
For today, whatever one works. It's not so much that you need the capabilities of the TI-84. You don't. All of the calculations you're going to do in this test are going to be simple calculations. They're just going to be multiplying and dividing numbers.
Okay.
So, first of all, what's the cost, including tax, going to be for the 2 lamps? 2 times what?
Let me read it real quick.
Okay. Each lamp is $8.99.
Okay.
So it's 2 times $8.99.
17.98.
Okay. You can do it that way, but let's figure out the tax at the same time. In other words, if there's a tax added onto that of 7%, what do I have to multiply that by?
0.07.
Actually, 1.07 will give us our answer. If I multiply it by 0.7, I'll get the tax, but then I got to add the tax to that first number. Whereas by doing it in one step, whenever you're talking about a tax or a discount, if something is a 20% discount, then you want to multiply it by 80%, 0.8, and that answers the problem in one step. You don't have to do this in 2 steps. In fact, you were going to do it in 3 steps because you were going to do that times that, and then you're going to take that answer, multiply it by 0.07, and then you're going to take that answer and add it to this number. So that would actually been 3 steps, whereas we can do the whole thing in one line on your calculator. If you use parentheses, you don't even need to use parentheses. It's that times that times that. Whatever that gives you as an answer. So that's your cost. Now, the rest of the question. You have $21 bills. Well, first of all, what is that? Do you have that?
Yeah, I have that.
What is that number?
19.23.
19.23. So your bill is $19.23. How much will you need in coins to have exact change? Whoa, hold on. I got to erase some of this stuff so I can read that question. How much will you need in coins if you want to have exact change ready? Is this rounded off? It's 1923?
No, it's rounded off to be 19.24.
Okay. Let's make sure we do that right. Because it makes a difference. That's a difference of a penny. In other words, it's not an insignificant number.
Yeah.
So read the last question, read the last sentence, figure out what they're asking. It's also a deceiving question. Here, let me give you a hint. I'm going to cross that off. That's totally unnecessary.
Okay.
How much do you need in coins if you want to have exact change ready? Look at all your answers. They're not asking you how much change you'll get back if you give them the $21 bills. That's not what they're asking.
Okay.
That would be 76 cents, right?
Mm-hmm.
If you want to pay without getting change back, and you do this all the time, whenever you go to a fast food restaurant, you go to McDonald's and the bill is $5.24. If you got $5 and you got 24 cents in change, you don't give her $6, you give her $5.24, don't you?
Mm-hmm.
So, what's the answer to this question?
A.
Yeah, it's real simple. How much in exact change is this amount right here, right? Now,
Yeah.
I
Okay.
suppose they put the $20 bills in there because theoretically you could pay the whole bill with exact change, right?
Right.
So you could have 24 cents plus $1. You could also have that much exact change. But if you look at your answers, all four answers are less than $1. So the question is, are they asking you the amount of change you're going to get back if you pay them $21 bills, or are they asking you if you pay them 19 $1 bills and give the rest an exact change, how much exact change would you do? That's what they're asking.
Yeah. Okay.
Okay, so a little confusing intentionally. I'm not sure these are kind of some old test questions. And boy, we've already come across about half of them have intentionally confusing stuff in there where they're trying to throw you off. And
Yeah.
I'm not sure that they do that quite as much in the recent tests I've seen.
Okay.
Nonetheless, it's good to know that every piece of information they give you isn't always necessary. Now, next one, I'm just going to do it. We're going to do this algebraically, or we're going to do it back solving. We're going to do it picking numbers. What are we going to do?
You back solving, yes.
Not so easily, because they're not asking about R. If they were asking about R, then you're right. I would just take these numbers and see which one of them cubed equals 343. But because they're asking about 3R, back solving isn't really the best way to go. It's not
Okay. Yeah.
easy to take these numbers, and I guess what you could do is take each of these numbers, divide it by 3, and then you'd say, okay, that's R. Now I could back solve it and see if this is true. So you're right, it could be back solved, but they're allowing you to use a calculator here. Why would you do anything other than algebraically solve it in your calculator? What's R?
R would be 7.
And what's 3R?
21.
So that's clearly easier doing it algebraically, especially since you have a calculator. If you didn't have a calculator, then it'd be a different story. Then I would, if I didn't have a calculator and I didn't know the cube root of 343, I would back solve it. In other words, I would start with dividing that by 3, dividing each of these answers by 3, and checking which of those numbers cubed equals 343. So, all right, let's see if we can go to another page. And 21, put those in order. You don't even need the answers.
Okay.
What you need, because the answers aren't helpful. In other words, here's the three numbers: pi, 7/3, and 9/2. Put those in order from smallest to largest.
Okay.
What's your strategy going to be?
Well, I know a pi. I recognize pi easily, but then I look at 7/3 and 9/2.
What's pi?
Like in its number form, or?
That's the key question. In order to compare pi with 7/3 and 9/2, what do we need to do?
Put in a fraction?
You can't put pi as a fraction. There is no fraction for pi. There's an approximate decimal. What's the decimal approximation?
3.1. Just put 3.14.
Okay, now what do we need to do with everything else?
Put everything else in a decimal.
Okay, what's 7/3?
2.3.
And what's 9/2?
4.5.
Now it's easy. In other words, once you get them so that they're all in the same format, it's easy to order them.
Yeah, that makes sense, yeah.
Now, I suppose you could have done something. You can closely approximate pi with 22/7. That doesn't help a lot because comparing 22/7 with 7/3, I guess you could eventually get there. But notice that I would almost have to find a common denominator, convert them all to that common denominator in order to be able to compare them. Whereas if I convert it to decimals, it's a piece of cake instantly. Even though I'm rounding off pi, it doesn't matter. All right, let's go through this little game again. What could possibly be wrong here? Okay, that's big enough, I guess.
Yeah, that's good.
Do 23. Gonna do it algebraically, back solving. I'm not even gonna pick numbers. You want to pick numbers when there's variables and answers and the questions. There's actually some other cases where you'd want to pick numbers also, but primarily you're going to be faced with two options: algebraic or back solving.
I think algebraic.
Yeah, you can't even back solve this one. I wouldn't even know where to begin if I started and assumed that was the answer. I wouldn't know what to do next. So back solving doesn't help at all. So algebraic, how do we figure out slope between 2 points?
Let's see, y2 minus y1 over x2 minus x1.
Do it. Now here, you're almost safer not doing it on a computer or a calculator.
Yeah.
So plug in everything. All four values.
Yeah, okay. I got it.
What's y2?
Y2 is -7.
Keep going.
And then 4, -4. And then over 2, -5.
Okay, what's that answer?
See, -11 over -3.
Which is, that's the answer that we're looking at. We got some multiple choices here.
Wouldn't that just be B?
Uh-huh.
Yeah.
Did you use your calculator for any part of that?
No.
Okay. It's almost easier to not use your calculator when you're dealing with single digits. If you're really comfortable, in other words, there's different calculators that you have to do that problem right there differently. I've got a 4-function calculator that does that entirely differently than my TI-84. My TI-84 has a subtraction key and it also has a negative sign key. And you got to know which one to use. So it's actually fairly easy to take an unknown calculator and get the wrong answer if you try to do that in a calculator. So it's almost safer to do that in your head as long as you're really good with single-digit operations. And I think you're good enough that you would not make that mistake. All right, now we get into some prime number factors. Or I'm sorry, not prime numbers. Greatest prime factors.
Okay.
So P is the greatest prime factor of 38. Tell me what that is.
Like the greatest number you can multiply that 38 is divisible by.
Well, it says the greatest prime factor. So let's talk about 38 and factors of 38. Let's figure them all out. What's the next two?
So 1 and 38, 2 and 19.
Okay. I don't see any more.
No, I think that's it.
What's the greatest prime factor? That's not prime.
19?
That's prime.
Yeah.
Okay. So P equals 19. F is the greatest prime factor of 100. So now let's do the same exercise with 100. Let's break it down. Go.
250. 3 and 4. No, sorry, 3.
Here's what I do, and I think the technique works great. Always try to cut the number on the left by half if you can, because then you can just double the other side. Well, I can cut 50 in half. Now, I can't cut 25 in half anymore. I can't cut it in thirds, but I can cut it in fifths. So if I cut 25 in fifths, and now I got to multiply the right side by
5 and 20.
And now I notice that I can cut 20 in half, double 5, so there's another factor. And I think I have them all. Of all the numbers on that list, what is the greatest prime factor? In other words, out of all 10 of those numbers, which is the greatest prime number? What's the biggest prime number?
25.
25 is not prime. If I can divide it by something other than 25, it's not prime. Remember what prime is. It can only be divided by itself or 1. Two's prime. What other number in that list is prime?
5.
That's it. Those are the only two. So F is 5. Now what's P plus F?
24.
Okay, let's look at 25. That's a good problem too. I don't know. Can you see it? Can you read 25 okay?
Yeah, I can see it.
Okay. I'm going to write it out just to make it bigger. I want you to tell me what's the first thing you would do if you encountered this problem on the exam. They're giving you two things here. Of course, we can't be certain that all the information they're giving us is relevant, but usually on problems that are one-line problems like this, they don't stick irrelevant information in there. In other words, we almost certainly are going to need that piece of information. The places, if you'll remember, the places where they stick irrelevant information is in word problems where there's like 5 or 6 lines. And one of them will have a piece of information in it that's completely unnecessary.
Mm-hmm.
So here's what we're looking at. What should we do as a first step? Now, if you don't know what to do as a first step, do whatever you can do.
Okay.
What can you do? I'm given this piece of information and I'm given the second line. I'm going to erase this because that's what they're asking for. But if that's the only information I'm given, what's the only thing I can do? What's the one step that I can take that advances this problem?
I do not know.
Well, there's actually 2 things you could do. You could take the square root of both sides, and then you would have t plus v equals the square root of 289. But that's not particularly helpful. I don't have a t plus v anywhere. They're not even asking about t plus v. They're asking about t squared plus v squared. So what's the other thing you can do other than take the square root of both sides? How do you solve an equation? What do you get rid of?
Variables.
Exponents, denominators, parentheses. Let's get rid of the parentheses on the left. In other words, square that thing.
Okay.
That's really the only thing you can do other than taking the square root of it, of both sides, but that doesn't get you very far. I don't think, at least. I don't know. I've never done this problem that way before. I may have to examine it afterwards. But if you expand this, you will discover something quite interesting. Just expand that. How do you expand that?
So square both sides, and they have t plus b equals 17.
No, that's taking the square root of both sides. That doesn't help us.
I have no clue.
How do you expand t plus v squared? That's t plus v times t plus v. You got to FOIL it. FOIL it.
Okay.
So we get t squared. In other words, that times that is t squared. Then I get this times that. Then I get this times that. And then finally I get this times that. So give me each of those terms.
Okay. So t squared plus tv plus tv plus v squared.
That's equal to 289. I can turn that into 2tv. And they're telling me what tv is. So 2tv has to be 60. So now I got t squared plus 60 plus v squared equals 289. What does t squared plus v squared equal?
229.
Yeah. In other words, by expanding that, I produce their t squared, their v squared, and I have a middle term of t times v. So it works quite nicely if I do it that way. Now, I'm curious. I never have actually tried to do this the other way. It actually might be just as easy. Let's look at it. So I know that t plus v equals 17. And I know that t times v equals 30. Well, that's 2 equations and 2 unknowns. So I know I can solve for both t and v, and then I'll be able to square each one, add them together, and come up with an answer. But it's going to be a lot harder math. Notice that this isn't that easy to solve. That means t is equal to 17 minus v, which means 17 minus v times v equals 30. A lot of math. I go ahead and solve for v, then I solve for t, and then I square each one of them and add them together. And I could get to 229, but it's a lot more work. And that is actually the natural first step that you would take, would be to take the square root of both sides. It's just not the most efficient way to go. Much better to square that, and then you see all of a sudden, you see some TVs and you see some of that. And so the problem becomes a two-step problem once you square that. But you got to know how to square a binomial. That's an absolute critical process in algebra. And this is primarily an algebra test.
Okay.
It's actually equally algebra and geometry, as opposed to the SAT, which was much heavier on the algebra. Your SAT didn't have a lot of geometry, whereas this has almost an equal amount of geometry and algebra, and then a few trig questions thrown in. What math course did you just finish, Ben?
I just finished Algebra 2 Honors.
Did it have trig in it?
Yeah, we did trig a lot, yeah.
Okay. So you're good on these trig questions that you're going to get. You will get 4 of them. You get 4 trig questions on the ACT. You only get like 2 trig questions on the SAT. The difference is the trig questions on the ACT are much easier. The trig questions on the SAT tend to be hard. You almost have to have taken trig to get those 2 questions on the SAT. But on the ACT, you don't have to have taken trig at all. All you have to have taken is like a week's worth of trig. And you'll be able to get all 4 questions on the ACT, the trig questions. Let's do one more here. Since I got the page up, let's see if I can figure out what it says. I think it says x to the 3a minus 5 all to the 4th power is equal to x to the 44th power. Solve for a.
I think it's actually plus 5.
Okay. Could you back solve this?
I guess you could. Kind of hard.
Couldn't you? What does this have to be? How do you handle this double exponents here? It's not necessary to back solve it because it's so easily solved algebraically, and you need to know these rules of exponents. So let's and you're going to need to know the rules of exponents regardless of which way you solve it. But how do you handle double exponentiation like this? What's it equal to?
You just multiply it? I forget the rule. Did you just multiply them?
The rule, you multiply it when it's double exponentiation.
Yeah.
So now you have this. Now what?
And then to get rid of one of the exponents on one of the sides, you can do 1 over and then whatever the exponent is.
Now, if you have x to one exponent equals x to a different exponent.
Oh no, you can add them together.
You can equate them.
Equate them. Yeah, that's what I meant. Yeah.
And now the problem is easy. A equals 2. Well, we could have actually back solved it, maybe a little quicker, in the following way. We know that 4 times this has to equal 44. Well, that means that has to equal 11, right? And if that has to equal 11, A has to be 2. So if you're really into speed and you need to solve this question in about 10 seconds, that's probably the faster way to go. Rather than to even, well, that wasn't really back solve. I didn't back solve it. I apologize. You could try to back solve it, but then you might end up testing some of these really hard numbers. In other words, if something like this is one of the answers and you have to try back solving it, that's going to be a lot harder.
Right.
But you could algebraically solve it in just 2 steps if you are positive that 4 times this quantity has to equal 44, then this quantity has to be 11. A has to be 2. All right. Ben, is this going to be a regular time? Saturdays at 10? At least until you take your test?
Let me see what it was this next week. Determination. This will be, what is this, June 2nd? I will assume that it is, and then if not, I think I will let my mom know. I'll ask my mom.
You want it 11 or 10?
Let's do 10.
You got it.
All right.
I'll talk to you next Saturday at 10, and if your mom needs to reschedule or postpone it or whatever, just have her contact me.
Okay. Yeah, we'll do that.
All right. Ben, have a good rest of your weekend. Talk to you next Saturday.
All right, great. Thanks. Appreciate you too.